Okay, so with this particular video, we're going to be looking at how to work with polynomials. Now, if you'll notice from the screen that I have got pulled up, we've got some addition, subtraction, multiplication going on. What I'm going to do is I'm going to focus on the multiplication aspect of it because that's where we're also going to pick up the idea of adding and subtracting. So the directions simply ask us to perform the indicated operations. So I'm just going to do what it tells me to do. So I'm going to pick a couple of these problems that I have in this particular section. I'm going to work them out. So let me go to a whiteboard here. Let me stop my share, and we're going to share a whiteboard screen so we can look at that. All right. So the first one that I'm going to look at, this is actually number 14 from the book there. No, it's not going to let me write a 14. Try this again. There we go. Must have been up too high. So number 14 gives us this problem. We've got 3/4 r minus 2/3 s, and then parentheses 5/4 r plus 1/3 s. Okay, so because I see two sets of parentheses that are side by side, I don't have anything in between here. That means to me that I'm going to be multiplying. So there are a couple ways you can think about multiplying this. Because this is a binomial times a binomial, and what I mean by a binomial times a binomial is you've got two terms here, you've got two terms here. So we've got a couple of options. I can do something called FOIL. You've probably heard this in high school. I don't particularly like the idea of FOIL just because it only works when you have a binomial times a binomial. So I'm going to look at it a little bit differently, and it actually does the same thing. I just don't have to sit here and think about, oh, is it the first, or is it the outer, inner, last step? I don't have to worry about any of that. So what I'm going to do is I'm going to take this, get rid of some of the stuff here. There we go. I'm going to take this 3/4 r, and I'm going to give it to both things over here. And when I say give it to, I'm going to multiply it. So if I do 3/4 r times 5/4 r, 3/4 times 5/4, when you're multiplying fractions, you just multiply straight across. So 3/4 times 5/4 is going to give me 15/16. And then when I multiply r times r, that's going to give me an r squared. So when you multiply, you add the exponents. Okay, and then I'm going to do the 3/4 times the 1/3 s. So if I do 3/4 times 1/3 s, that's going to give me 3/12. Okay, so we've got plus 3/12 s, or excuse me, rs. All right, so now we are done with that particular term. So let's go back, and I'm actually going to take, let me get a different color here. I'm going to take this 2/3 s, and it's a negative 2/3 s, and now I'm going to go back and I'm going to give that to both of these terms. So I'm distributing is what I'm doing. So if I do negative 2/3 s times 5/4 r, I'm going to get negative 10/12 rs. And one of the things I want to point out here, it doesn't matter if you put SR or RS. Multiplication is commutative, so it all does the same thing. So I've got negative 10/12 RS, and then negative 2/3 S times 1/3 S is going to give me a negative 2/9 S squared. Okay, so we've got all of this stuff kind of multiplied out here. We're done with the multiplication step. Now we want to focus on, do we have any like terms? So do I have anything that I can combine together? And when I look at this, I see that, okay, I've got an r squared, so there's nothing that's going to combine with the r squared. I do have a 3/12 rs and a negative 10/12 rs. So when I say combine like terms, what we're looking for is, do we have the same variables? Do we have, or do those variables have the same exponents? So yes, we do have the rs on both of those terms. And then, of course, I've got the negative 2 nines s squared. That's a different variable than the r squared. So really the only two terms I have there in the middle are going to be what I combine together. So the 15/16 r squared, I'm just going to bring down. There's nothing I can combine it with. Here, though, if we do positive 3/12 minus 10/12. Now, we're lucky because we already have a common denominator. So when we do have fractions, you want that common denominator. So if I do positive 3/12 minus 10/12, that's going to give me a negative 7/12 RS. And then I'm going to bring down my negative 2/9 S squared. And that is our final answer for combining these things. All right, cool. So that was number 14. Let's go on and look at number 16. So on number 16, I'm going to change it a little bit. Instead of doing a binomial times a binomial, I'm going to do a binomial times a trinomial. So clear this out. Number 16. They give us 3p plus 2 times 5p squared plus p minus 4. All right, so I'm going to use the very same process that I did last time. I'm going to take this 3p and I'm going to give it to all three things in that second set of parentheses. And then I'm going to turn around and I'll do the positive 2 times all three things in that second parentheses. So if you do this distribution method, instead of trying to worry about FOIL wouldn't work with this particular problem. But if you do it the way we did the last problem, it's always going to work. Okay, so 3p times 5p squared is going to give me 15p cubed. Remember, when you multiply, you add exponents on these variables. And then I'm going to do 3p times positive p, which is going to be positive 3p squared. And then I'm going to do 3p times negative 4. And 3p times negative 4 is going to give me a negative 12p. So that is the first term taken care of. So let's go ahead and let me switch to a different color. Let's go back to blue. I'm going to take this positive 2 now, and I'm going to give it to all three terms in that second set of parentheses. So positive 2 times 5p squared is going to give me a positive 10p squared. And then positive 2 times positive p is a positive 2p. And then positive 2 times negative 4 is a negative 8. So we've taken these parentheses, we've multiplied them out. We've got a bunch of terms going on here, but we're going to go through and we're going to figure out what are our like terms. So I see this 15p cubed. So I'm looking for another p cubed to be a like term, and I don't see any other p cubed. So I'm going to bring down my 15p cubed. There's no more like terms for it. I see a positive 3p squared. I also see a positive 10p squared. That's a like term, so I'm going to combine these two things together. So I'm going to add 3p squared and 10p squared and get 13p squared. All right, what else we got going on here? I see a negative 2p, or excuse me, a negative 12p and a positive 2p. So if I add those two things together, a negative 12 plus 2 is going to give me a negative 10p. And then, of course, I've got this negative 8 on the end. That's the only constant I have. And when I say by constant, I mean it's a number that does not have a variable attached to it. So that's just going to come down, and that would be my final answer for this particular problem. All right, cool. Let's switch gears. I'm going to do another multiplication problem. And if you'll notice, guys, like I said, I'm getting the addition and subtraction in here as I do the multiplication by the combining like terms, so it works the same. So let me clear this problem. Let's do something that looks weird. So I'm going to do number 24. So number 24, they give me 2a minus 4b squared. Now, again, there's a couple of ways that you can do this problem. The one way that you cannot do this problem is by taking this squared here and just giving it to these two things. It does not work like that. That is bad. Do not do that. If you do, you're breaking math. So one of the ways that we can do this is that we can memorize a rule called the perfect square trinomial rule. And what that rule does is it tells us the process for going through and multiplying this. I actually think that's more difficult than just saying, okay, well, what does a square mean? If you have a square, that literally means You've got 2 of them. So what I'm going to do is I'm going to take and I'm going to write that set of parentheses twice. So these 2 statements mean the same thing, but by writing it like this down here on the bottom, it's exactly what I did on that very first problem that I showed you. So let's go ahead and let's multiply this out. Again, if you want to use the FOIL method, you can, because it's a binomial times a binomial. I'm going to do it the same way I've been doing those other problems. I'm going to take this 2a and I'm going to give it to both of these terms. So I'm going to multiply. 2a times 2a is 4a squared. 2a times negative 4b is negative 8ab. So I am now done with the 2a. So let me change colors. I'm going to switch gears, and I'm now going to take this negative 4b, and I'm going to give it to both of these terms. So negative 4b times 2a is going to give me a negative 8ab. Now again, BA, AB, it doesn't matter. It's all the same. I just like having all of my variables in order as I multiply. It makes it easier to find like terms. And then if I do negative 4b times negative 4b, I'm going to get a positive 16b squared. All right, so let's go through and combine like terms. We've got a 4a squared. That's the only a squared term that I see, so I'm going to bring it down. I have a negative 8ab and a negative 8ab. Those two things have the same variables and they have the same exponents on them. So I'm going to combine those two. So I'm going to do negative 8 minus 8 is going to give me negative 16ab. And then I've got a plus 16b squared. That's the only one of my b squared terms that I have. So I'm going to bring it down. And that is my final answer with this one. Again, guys, there is a rule that you can do. The rule basically says that if you've got a minus b squared, that's equivalent to a squared minus 2ab plus b squared. And so your a and your b come from these terms here. It's just it's a lot to have to memorize. So I think it's much easier just to write it twice and multiply it out. This is also a rule that you'll see come up in factoring. And in factoring, you don't have to use this rule either. If you want to memorize it, good for you. If not, perfect. Don't have to. Move on with life. All right, guys, that's all I've got on polynomials.